and pi, and based on the sigma bond, as you can see, sigma bonds are the head and overlap of atomic orbitals. As you can see the above here, basically this is the atomic orbitals, 1s and 1s of hydrogen, and they combine together to form a molecular orbital. This is the sigma bond of SS type. You can see also sp also can combine to form sigma of sp orbital, and here sigma pp orbital. And when it goes to the pi bond, it is the sidewise overlap of atomic orbitals. That means it can take place only in case of p orbitals, where the two p orbitals will be in parallel form from one atom and this is another atom. It is shown as like it's the nucleus. This is the p orbital lobes. Then they combine to form pi orbitals. This is the molecular orbital of pi orbital type. Now we'll go to see the characteristics of the covalent bond. As shown here, there in the ionic bond, they form crystals. Here, covalent bond formation leads to molecules. These are strong bonds, but the covalent compounds can exist in three forms: gas, liquid, and solid. It has relatively low melting point and boiling points compared to the ionic compounds. They are bad conductor of electricity. Covalent bonds are highly directional. As it is highly directional, it is because it forms due to the overlap of orbitals, and orbitals are perfectly oriented in one particular direction, as we have seen already, and we will discuss further ahead. And these directed covalent bonds forces the atoms to have a particular point in a molecule, and particularly in space. This leads to the structure of molecules. We will discuss in the next slides, as you can go the points. And before to go to the molecular structure, we will just another important point is the hybridization. What is hybridization? Hybridization is the combination of atomic orbitals which are of different energy, and they combine to form again new atomic orbitals which are of equal energy. These new orbitals are called hybrid orbitals. The process is called hybridization. We will go for some examples, then we can understand. We will take case of methane. In methane, the central atom is the carbon, and the carbon will have 6 electrons, and they arrange 1s2, 2s2, and 2p2. If you see this only valence cell, that if you see this is the energy increasing, then 2s orbital will be here and p orbitals will be here, and the 2 electrons here and 2 electrons will be arranged here. But when it is going to form CH4, in this case, these 4 orbitals combine to form equal energy levels. These are called sp3 hybrid orbitals. If you see in the picture wise, here this is the s orbital and 3p orbitals. They combine to form 4 sp3 hybrid orbitals, and this structure they will arrange in a tetrahedral manner. These p orbitals, they will be combined with the 1s orbital of hydrogen atom, and now the structure of the molecule look like this. That is in a tetrahedral. The structure is tetrahedral. And next we'll go see the another example in case of ethane, where there is sp3 hybridization was taking place for in case of methane, but in case of ethane there will be sp2 hybridization. Hence 1s and 2p orbitals. Now and one unhybridized p orbital is left behind. These are the 3 hybrid orbitals in a triangle manner, where the angle will be 120 degree, and here the unhybridized p orbital will be perpendicular to the plane. This they combine in case of ethane. The sp2 hybrid orbitals form sigma bond 1 here, and another 2 are here, another 2 are here, but the p orbital is overlapping in sideways manner. So as we can find all these 3 orbitals in the plane, so total molecule will be in a planar structure. Then again we will see the structure of the molecules. Now the point is come BAC pair theory. This theory explains how the structure will be. Although there will be so many other parts of the theories will come which will decide the structure of the molecules, but this is the main theory which decides the structure of the molecule. According to this theory, electron pairs surrounding a central atom repel each other. That means, if you see the example of a methane, the bond pairs of all CH bonds will be repel each other. and the order of repulsion among the lone pair and bond pairs will be like this. That is, lone pair repulsion is more than lone pair bond pair and bond pair. Then let's see how this theory explains the molecular structure as we go ahead. Let's take the case of ammonia. Here the center atom is nitrogen, will be surrounded by 3 hydrogen atoms. That means the nitrogen atom will have 7 electrons and they will be arranged like this. That means P will be 3 electrons and S will be 2 electrons for the valence shell. And these 4 orbitals undergo hybridization, form sp3 orbitals, and these 4 sp3 orbitals will be around like this. And from this, one sp3 orbital will contain the lone pair. Another 3 hybrid orbital will have unpaired electrons and they will combine with 1s orbital of hydrogen to form bond, and they will be arranged like this. In this point, this lone pair will repel the bond pairs to squeeze, and this angle becomes 107 degree, which is, whereas a normal tetrahedral structure have angle 109 degree and it has reduced to 107 degree, and the structure becomes a trigonal pyramidal. Very similarly, it is case for water, where there will be 2 lone pair. As you have seen, the lone pair repulsion is more than lone pair bond pair, and again bond pair. These 2 bonds become squeezed and the angle reduces to 104 degree 5 minutes, 104.5 degree. As you can, we have compared all these 3 structures here. So this methane, ammonia, and water. As we can see, for methane, this angle is 109 degree 28 minutes. This is the normal tetrahedral structure. But in case of ammonia, it becomes 107, and for water, it is 104 degree 30 minutes, 104.5 degree. This is basically, we have come to the ionic bond and covalent bond. And another 2 bonds I will just explain a little bit. That is coordination bond, or also called dative bond pair. One atom shares 1 electron pair, but whereas other atoms, 1 or more, is like that. One atom donate a pair of electrons, and 2 or more atoms share the lone pair, share the electron pair. Take the case of example of ammonia, where nitrogen having 1 lone pair, which we have seen just before. This lone pair will be given to one of the proton, H plus. Now the dative bond will become a covalent bond, and it will be shown as like this. And now after the formation of the ammonium ion, all bonds are equivalent. Next bond type is hydrogen bond. In this case, there will be interaction between an electronegative atom or group with a hydrogen atom, which is also combined to a electronegative atom or group, a different electronegative atom or group. Is the example of like a water molecule, we can say, where this is oxygen, this is hydrogen, and this hydrogen will have a small interaction between the oxygen of another water molecule, and similarly the same other atom molecules combined with the other, and there will be large number of water molecules. This hydrogen bond, as we have listened to, we have read many cases, is that this water molecules, water is a liquid, whereas H2S is gas. This is due to hydrogen bonding or interaction. Okay, there is a lot of discussions about hydrogen bonding, dative bond. We are not going to deep into that, and we are just finishing about the all types of things here. As we have now gone to the conclusion point, where it is the structure of atoms, where how the electrons are arranged around the nucleus, and this structure of atom responsible for the bonding between the atoms, because we want to be, the electrons should be paired off. The pairing of electrons forms ions. When the pairing of electrons forms ions, this becomes ionic bond, and ionic bond related to the crystal structure. This is combining structure of atom, then bond, then structure again. Very similarly, again, when the electron pairing takes place in sharing of electron takes place, then they form covalent bond. And again, the covalent bond leads to molecules, and molecules have a particular structure. So again, we are coming the structure back. Structure, bonding, structure. So here I want to make the point is that structure of atom responsible for the bonding, and bonding responsible for the structure of different groups. I would like to thank you for your kind attention. Bye.